Good morning everyone. I am Garima from BSc Chemistry Honors second year. Today I am going to start chapter Diazonium salts introduction. Diazonium salt discovered by Peter Greece in 1858 constituted a very important class of aromatic compound having the general formula Ar(N2 positive X negative, where X negative may be anion such as Cl negative, Br negative, H2SO4 negative, NO2 negative, BF4 negative. The name diazonium itself originated from the fact that these compounds contain two nitro uh, uh, atoms. It may be pointed out that aliphatic diazonium salt, that is compound having N2 positive X negative group attached to alkyl radical, are too unstable to be isolated structure. The simplest and most important diazonium salt is benzene diazonium salt. Let us first consider the structure of this compound as representative of structure of diazonium salt in general. Important evidence leading to its structure may be summed up as follows. Molecular formula. Its molecular formula is C6H5N2Cl. Observed behavior. It is colorless crystalline solid, soluble in water but insoluble in organic solvents such as alcohol and ether. It undergo ionization in aqueous solutions such as conductivity measurement of solution. Thus, benzene diazonium chloride exhibits salt-like behavior. It undergoes many substitution reaction in which N2Cl group is replaced by monovalent group such as halogen cyanide. It undergoes coupling reaction to form azo compounds such as para-hydroxyl azobenzene. On reduction with stannous chloride and hydrochloric acid, it is reduced to phenylhydrazine. In alkaline solution, it forms a salt known as diazotates, which exhibit geometrical isomerism. Easier formula. Grease formula. The earlier structure formula for benzene diazonium chloride was suggested by the discoverer Peter Grease. In this formula, the two nitro atoms were directly attached to benzene ring as shown. However, this formula was immediately rejected as it cannot account for the following properties of benzene diazonium chloride. First, its salt-like character. It's reducing to phenylhydrazine, which contains only one nitro directly attached to benzene nucleus. The displacement of N2Cl group as a whole in most of the reaction. The formation of azo compound in coupling reaction. Kekulé formula. Kekulé proposed the following structure in which only one nitrogen is attached to benzene ring. This formula could explain most of the reaction of benzene diazonium chloride, but it failed to account for salt-like behavior of benzene diazonium chloride, instability of benzene diazonium chloride as compared to azo compounds, since both contain N double bond N linkage. Blomstedt formula and its modified form. Blomstedt suggested the following structure for benzene diazonium chloride. The structure has now been modified as benzene with attached N positive triple bond N and Cl negative, suggesting evidence. The above ionic structure, which is comparable to that of ammonium chloride, is suggested by following observation. Benzene diazonium chloride is soluble in water but not in organic solvent due to salt-like structure. Conductivity of aqueous solution confirms the presence of charged structure. IR spectra shows the presence of nitro triple bond. It can explain all the reactions of benzene diazonium chloride. It can explain existence of geometrical isomer of diazotates. It has been suggested that the presence of hydroxide ion, the diazonium ion, exists in equilibrium with diazohydroxide and the salt derived from it as shown below. The concentration of different species depend on pH of solution. In acidic solution, the equilibrate favors diazonium ion, while in alkaline solution, the equilibrium are in favor of diazotates. The diazotates can naturally exhibit geometrical isomerism and exist in syn or cis and anti-trans form as depicted below. Nomenclature. Diazonium salts are named by attaching the word diazonium to the name of parent aromatic compound. This is followed by the name of anion. For example, benzene diazonium chloride, para-toluene diazonium bromine, para-chloro-diazonium fluoroborate. Preparation of diazonium salt. Diazotization. Diazonium salts are usually prepared by the reaction between aromatic primary amines and nitrous acid at 273 to 78 Kelvin. This is called diazotization and is represented as primary aromatic amine plus NaNO2 plus HX with 273 to 78 Kelvin give diazonium salt plus NaH plus H2O. Procedure for diazotization. For carrying out diazotization, the amine is dissolved in aqueous solution of mineral acid and resulting solution is cooled at 273 Kelvin. A well-cooled aqueous solution of sodium nitrate is then added slowly, taking care that temperature of reaction mixture do not rise above 278 to 283. If temperature is allowed to rise higher, the isonium salt form get converted into phenol. Addition of sodium nitrite solution is stopped as soon as few drops of reaction mixture give blue color with starch potassium iodide paper, indicating the presence of some unreactive nitrous acid in a reaction mixture. In other words, it's shows the complete diazotization. Since excess nitrous acid is likely to interfere with the subsequent reaction of diazonium salt, it is destroyed by adding a small quantity of urea. Any urea left unreacted do not interfere with the reaction of diazonium salt. Above solution containing diazonium salt is used as such for other reaction and no attempt is made to isolate the pure salt. This is because dry diazonium salt often undergoes explosive spontaneous decomposition. Furthermore, since diazonium salt decomposes slowly even in cold solution, the solution must be used for further reaction immediately after preparation. Precautions to be taken. During the preparation of diazonium salt, the following precautions should be taken. Temperature must be carefully controlled and not allowed to rise above 283 Kelvin, otherwise a phenol would be obtained. The mineral acid should be used in excess, otherwise diazonium salt formed would combine with undiazotized amine. Excess of nitrous acid must be destroyed. Never try to prepare pure dry salt because it is highly unstable and undergoes explosion decomposition. Mechanism of diazotization. It has been shown by Luckworthy that the actual mechanism of diazotization depends upon extent of acidity and concentration of reaction, but this is no doubt that nucleophilic amine undergoes attack by some electrophilic species such as nitrosonium ion or nitrous anhydride obtained from nitrous acid. Thus, one of the probable mechanisms which appears to operate in many cases may be summed up as follows. In the presence of strong acid, nitrous acid dissociate to give nitrosonium ion. The ion attacks the nitrogen of amine to form unstable N-nitroso-ammonium ion intermediate. The intermediate immediately loses a proton to form N-nitroso-amine. This in turn undergo rearrangement by proton shift to form diazohydroxide. Finally, in the presence of acid, diazohydroxide loses water to form diazonium ion. Diazonium salt containing anions such as Bf4 negative are generally obtained from more common diazonium salt as shown below. Benzene diazonium chloride plus fluoroboric acid. Benzene diazonium fluoroborate plus HCl. Physical properties. Diazonium salt are generally colorless, crystalline solid, freely soluble in water. They are seldom isolated because of their instability and explosion nature. With certain metallic salts such as zinc chloride, diazonium salt form double salt which is quite stable. Chemical properties. Diazonium salt are highly reactive compounds and extremely useful and as intermediate in preparation of many aromatic compounds, but by the use of diazonium salt as intermediate, it is possible to introduce onto the aromatic ring substituent which are difficult or impossible to introduce by other method. In addition, it is also possible to introduce the substituent in position not favor otherwise in a direct process. The reaction of diazonium salt may be divided into two main types. These are reaction in which N2 is given out and diazonium group is replaced by some other atom or group. Coupling reaction in which nitrogen atom are retained in the product. As already stated, diazonium salt are employed in various reactions in the form of their aqueous solution which are prepared just before they are required to be used. The important reaction of diazonium salt are discussed below. Reaction in which nitrogen is lost as N2 and diazonium group is replaced by some other atom or group. Replacement by Cl, Br or Cn. Sandmeyer reaction. A very important reaction of diazonium salt is the Sandmeyer reaction in which diazonium group is replaced by chloro or bromo acid atom or cyanide group. The reaction is carried out by treating solution of freshly prepared diazonium salt with cuprous chloride, bromide or cyanide. They we are ArN2 positive X negative plus CuCl will give ArCl plus side product. ArN2 positive X negative plus CuBr will give ArBr plus N2 plus CuX. Gutterman reaction. In a modified procedure known as Gutterman reaction, replacement by ClBrCn is carried out by using copper powder and halogen acid or potassium cyanide in place of cuprous cyanide. That is ArN2X with CuHCl will give ArCl, CuHBr will give ArBr, CuKCl will give ArCn. Second, replacement by iodine. Replacement of diazonium group by iodine can be brought about merely by warming the diazonium salt solution with potassium iodide solution. Mechanism. The reaction proceeds by SN2 mechanism. I negative ion being the attacking species constitute the best method for introducing iodine onto the aromatic ring. Replacement by fluorine. Bald's-Sickman reaction. For replacing diazonium salt by fluorine, the diazonium salt solution is treated with fluoboric acid HbF4 when diazonium fluoborate ArN2 positive BF4 negative get precipitated. The precipitate is filtered, washed, and dried to isolate the fluorborate. The dry salt on heating decomposes to yield aryl fluoride, bromine trifluoride, and nitrogen. The reaction known as Wald-Skigman reaction may be depicted as ArN2 positive X negative plus HbF4 will give ArN2 positive BF4 negative, which is insoluble, plus HX. Replacement by OH. On warming an aqueous solution of diazonium salt, diazonium group is readily replaced by OH to yield a phenol. ArN2 positive X negative plus H2O will give AROH plus N2 plus HX. Mechanism proceeds by SN1 mechanism as given below. Replacement by NO2. This is carried out by decomposing diazonium fluoroborate with sodium nitrite solution in the presence of copper powder. Thus we have ArN2 positive Cl negative plus HbF4 will give ArN2 positive BF4 negative. ArNO2 plus N2 plus NaBH4. Synthetic utility. The reaction can be used for introducing nitro group in specific position in benzene ring. Refer to the preparation of para dinitrobenzene from aniline. Replacement by aryl group. Gomberg-Beckmann reaction. Many diazonium salt react with other aromatic compound in alkali solution to furnish compounds in which diazonium group have been replaced by aryl group. For example, the example is given replacement by arsonium acid group ASO3H2 Bart reaction. This is carried out by decomposing a diazonium salt with sodium arsenide in the presence of copper salt. Example is given replacement by hydrogen. Replacement of diazonium group by hydrogen can be best carried out by allowing the diazonium salt solution to stand in contact with hypophosphorus acid, preferably in the presence of cuprous ion. The reaction may be represented as shown below. The reaction proceeds by free radical mechanism as illustrated below. Reaction in which nitrogen atoms are retained in the product. Reduction to hydrazine, no loss of nitrogen. On reduction with reducing agents such as stannous chloride and hydrochloric acid, sodium bisulfide or sodium sulfide, diazonium salt are reduced to hydrazenes. For example, benzene diazonium salt plus Na2SO3 plus H2O will give phenyl hydrazine hydrochloride. Free hydrazine can be obtained from its salt by reaction with sodium hydroxide. Coupling reaction. Important group of reaction of diazonium salt involved in the reaction of diazonium ion with aromatic compound containing full electron releasing substituents such as OH, NH2, NHR, NR2. The reaction known as coupling leads to the formation of compounds called azo compounds having the general formula where G is the substituent such as OH, NHR, NH2, NR2. The azo compounds are strongly colored compounds which constitute a group of dye known as azo dye. The coupling reaction in general may be depicted as follows. It may be noted that nitrogen of diazonium salt is retained in the product and the reaction generally takes place in para position with respect to substituent present on aromatic ring being attached. However, if the para position is already occupied, the attack occurs at ortho position. Mechanism of coupling reaction involves the usual electrophilic aromatic substitution in which Diazonium ion is the attacking reagent as shown below. It may be pointed out that diazonium ion is very weakly electrophilic. This is why it can attract only very reactive aromatic ring, that is the ring which contains strongly activating substituent. However, if the electrophilic character of diazonium ion is increased by introducing electron withdrawing substituent like NO2 into aromatic ring of diazonium ion, coupling may takes place with even less reactive aromatic compound. Choice of experimental conditions. An important factor to be taken place of the coupling reaction is the choice of suitable experimental condition. The reaction condition should be such that the coupling takes place rapidly and the position side product are prevented from taking place. The most important reaction condition which required to be regulated is pH of reaction medium. It is illustrated below in the reaction of coupling with phenol and tertiary amine. Coupling with phenol. When treated with phenol in weakly alkaline solution, diazonium salt undergo coupling to form hydroxyazo compound. For example, by benzene diazonium chloride plus phenol in the presence of weakly alkaline will give para-hydroxyl azobenzene plus HCl. Reaction with primary and secondary amines. Primary and secondary amines generally react with diazonium salt in mildly alkaline solution to form colorless diazoamino compounds. In this reaction, attack of diazonium ions takes place at amino nitrogen rather than on the ring. However, diazoamine compound thus formed undergo rearrangement when heated in acidic medium to form colored azo compound. For example, benzene diazonium salt plus aniline with CH3 C double bond O Na will give diazoaminobenzene. On treating with H positive heat give para aminoazobenzene. Synthetic application of diazonium salts. In introduction, the chemical behavior of diazonium salt, it was stated that diazonium salt can be employed as a very useful intermediate in the synthesis of number of aromatic compound, many of which are difficult or impossible to synthesis by other method. The preparation of orthotoluic acid, metabromophenol and 1,3,5-tribromobenzene was cited as some examples of synthetic utility of diazonium salt. A few more examples are given below by a way of further elucidation. So here our chapter diazonium salts is completed. Thank you.